The way we power our world is going through a massive, once-in-a-generation change. It's a really complex story, right? With new tech and new rules popping up all the time. But what if we could unpack it all together as a single connected story? Well, that's what we're going to do. We're going to open the book on our energy future and turn the pages chapter by chapter. To really get a sense of the scale of this story, let's just start with one number. $2.2 trillion. That's what the world is expected to invest in clean energy in 2025. Now, that's not just a big number. It's 2/3 of all energy investment on the entire planet. So that tells you the plot is already moving. The future of energy is being rewritten as we speak.
So here's our table of contents for today. We'll kick things off with Chapter 1, the Renewable Foundation, where the power actually comes from. Then, in Chapter 2, we'll get into how we convert and store it. Chapter 3 is all about using that power as smartly as possible, and we'll wrap up with Chapter 4, the intelligent network that has to tie this whole thing together. It's a story that builds, from generation all the way to management.
All right, let's open up to Chapter 1, the Renewable Foundation. This is ground zero. It all starts with the absolutely massive growth of clean power generation. I mean, the pace of change here is just staggering. In 2024 alone, the world added 741 gigawatts of renewable capacity. To give you some perspective, that is the biggest single-year jump we have ever seen. And this explosion, which is mostly solar, is happening because the supply chains are there and the costs have just plummeted.
And get this, it's not just about building more solar panels, it's about building them smarter. Just look at the leap in efficiency we're seeing. Your standard silicon panels, they're pretty good, around 21 to 23% efficient. But these new Perovskite silicon tandem modules, they're already pushing 27%. This constant innovation is what's really driving this whole renewable foundation forward.
And hey, our renewable foundation is not just a solar story. Not by a long shot. It's a whole portfolio. You've got floating offshore wind, which is unlocking huge new areas of the ocean. Hydropower is still the heavyweight champ for both generating power and storing it. Then you have geothermal, which gives us that steady, reliable, always-on baseload power. And you can't forget bioenergy, where new breakthroughs are actually creating carbon-negative fuels. The big takeaway here? This foundation is rock solid precisely because it's built from so many different things. Okay, so we're generating unbelievable amounts of clean power. Awesome. But, the sun isn't always shining and the wind isn't always blowing. So how do you make sure that power is there whenever we need it 24/7? Well, that question brings us to Chapter 2, Energy Conversion and Storage. One of the key answers here is green hydrogen. It's a super clean fuel that's perfect for the tough stuff, things like heavy industry or shipping that are really hard to just plug into a wall. And the magic ingredient for making it? Electrolyzers. They really are the technological backbone. They take renewable electricity and use it to split water into pure hydrogen and oxygen. Pretty neat. But, not all electrolyzers are created equal. You've got a few different flavors. There's alkaline, which is kind of the mature, cost-effective workhorse of the group. Then you have PEM, which is much faster to respond, making it perfect to pair with renewables that go up and down. And then you have these emerging techs like solid oxide and AEM, which have their own unique superpowers. The point is, you need the right tool for the right job in this new hydrogen economy. And the other massive pillar of energy storage is, of course, batteries, specifically the ones in electric vehicles. Demand is projected to just explode, a 14-fold increase by 2030. So you have to realize, EV batteries aren't just for getting from point A to point B anymore. They're becoming this giant, spread-out network of energy storage that can actually help power the grid. So we're making the power and we're storing the power. But what about how we actually use it? Because the smartest, cleanest energy is always the energy we don't have to produce in the first place. And that brings us to Chapter 3, Efficiency and Circularity. You hear this phrase a lot. Energy efficiency is the first fuel. And it's true. It's the cheapest and cleanest resource we have. For companies, it's a total win-win. It makes them more competitive by saving money, and it helps them decarbonize. We're not just talking about turning off the lights here. This is about deep, strategic energy management, using tools like AI to squeeze waste out of every single process. Okay, let's circle back to those EV batteries for a second, because this is really important. This chart tells a fascinating story. It shows that the biggest environmental hit from a battery doesn't come from driving the car, it comes from making it. Just producing the cathode accounts for over a third of the emissions. And that fact right there is why building a circular system, one based on reuse and recycling, is totally non-negotiable.
So we have to stop thinking of a battery's life as a straight line from factory to landfill. We have to think of it as a circle. It starts with manufacturing, where you design the battery to be easily taken apart later. Then it has its first exciting life in an electric car. But when it can't do that job anymore, it gets a second life as stationary storage for the grid. And then finally, at the very end, it gets recycled to recover all those precious minerals, the lithium, the cobalt, the nickel, so they can go right back into making new batteries. That's how you close the loop.
And even the recycling itself is getting way smarter. The old method, pyrometallurgy, is kind of like a brute force approach. You just melt everything down at super high temperatures. It works, but man, it uses a ton of energy. The newer method, hydrometallurgy, is more surgical. It uses chemicals to carefully leach out the valuable materials. You get more back, and as you can see, it has almost 50% lower emissions. It's really the only way forward.
Okay, so let's just take a breath for a second. We have all these different renewables, we have sophisticated new ways to store energy, and we have a much smarter, more circular way of using it. This is creating a system that's incredibly powerful, but it's also incredibly complex. So the huge question becomes, how on earth do you manage all of this? And that question leads us right into our final chapter, Chapter 4, the Intelligent Energy Network. This is the digital brain and the official rulebook that makes all these different parts work together like a symphony. At the heart of it all is the smart grid. The easiest way to think about it is like upgrading our old one-way power grid into a two-way energy internet. It's packed with digital sensors and communication tools that constantly watch and manage the flow of electricity, perfectly balancing supply from, say, a wind farm with demand from our homes and EVs, all in real time. Now, for a smart grid to work, you need a digital backbone built on trust. And that comes down to three key things. First, interoperability, which is just a fancy way of saying all the different parts need to speak the same language. Second, traceability. You need to be able to prove where energy and materials came from, and that's what things like the new EU digital product passports for batteries will do. And third, you need a clear mandate. For example, starting in 2027, these battery passports will be mandatory, and you'll be able to access them with a simple QR code. But all this amazing technology is one thing. It can't do it all alone. It needs a clear rule book to play by, and that's where policy comes in. Frameworks like the EU's Fit for 55 package give markets the direction and the certainty they crave. By setting a huge target, at least 42.5% renewables by 2030, it tells every investor, every company, every innovator exactly which way we're headed. But, as you can imagine, policy isn't always so simple. This slide shows the challenge perfectly. In 2023, while EU countries spent about 145 billion euros helping people with high energy bills, they also spent a jaw-dropping 136 billion on fossil fuel subsidies. It just goes to show the tough balancing act governments are facing. These subsidies are often baked into the economy to keep prices stable or protect jobs, and that creates this powerful inertia that can really slow down the transition. Ultimately, what this final chapter teaches us is that bringing everything together, the tech, the markets, the people, it all requires coordinated governance. It's the only way we're going to get the massive investment we need, and it's the only way to make sure this transition is fair for everybody and strong enough to handle future shocks. So, we've read through the chapters of our modern energy system. The tech for generating, storing, and efficiently using clean energy is moving at lightning speed. The policies that act as the rulebook are starting to take shape, but the final critical piece of the puzzle is coordination on a global scale. And that leaves us with one last big question to think about. Are we going to build this complex, intelligent system together as one team, or are we going to build it in fragmented, competing pieces? The answer to that question will define our energy future.